Find the derivative using the limit definition. Oh, this one's going to be fun. The limit definition of the derivative is this. The limit as h, you might be thinking, what's h? You'll see. The limit as h approaches 0 of f of x plus h minus f of x all over h. This will give you the derivative. It's a mess, and there are shortcuts, but this is the problem that I created, so this is the problem that we're going to do. What I like to do is I like to take turns writing out what this is going to be, f of x plus h, and then kind of like plugging everything in and magic will happen. But the first thing I need to do is find out what f of x plus h is. So to find f of x plus h, you need to rewrite this original equation. And remember, y and f of x, same exact thing. You're going to rewrite this equation, and you're going to replace every x value with x plus h. So f of x plus h is negative x plus h in parentheses squared plus 2 times x plus h in parentheses plus 1. So what I'm going to do is I'm going to write out that x plus h squared is a perfect square trinomial. I can FOIL this, split this and FOIL it, but I'm going to be a little lazy and just say that becomes x squared plus 2xh plus h squared. This is distributive property, so plus 2x plus 2h and then plus 1. Distribute this negative, negative x squared minus 2xh minus h squared plus 2x plus 2h plus 1. Now, you might be thinking, oh, please let one of these guys cancel out. It won't, but don't you worry. It will, something eventually will cancel out. Now, what I'm going to do is I'm going to, over here, rewrite this guy, right? I already know that f of x plus h is this. So I'm going to write out the limit as h approaches 0 of f of x plus h, which is blah, 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 blah. So negative x squared minus 2xh minus h squared plus 2x plus 2h plus 1. Now, I'm going to subtract f of x. I know what f of x is. It's that guy. So remember, when you subtract, and I'm going to skip a step, when you subtract a polynomial, you are distributing a negative. So when I subtract this green parentheses, flip the sign. So you become plus x squared, that's good news, minus 2x, that's good news, and minus 1, that's good news. Now you might be thinking, why? Remember how I mentioned magic before? Well, things are going to disappear. First, I need to put this all over h. Negative x squared and x squared cancel out. You should expect this to happen when you do problems like this. What else cancels out? 2x, negative 2x, positive 1, negative 1. So I now drop down the limit as h approaches 0 of negative 2xh minus h squared plus 2h. Now you might know from limits and computing limits algebraically that if I were to plug in 0 for h, and h, I would get 0 over 0, which is indeterminate, which is against the rules. But if I have an h in common with all of them, can I just factor out an h? I'll tell you, you can. So the limit as h approaches 0 of, let's pull out an h, negative 2x minus h plus 2 over h allows me to cancel out these h's. I missed. So the limit as h approaches 0 of negative 2x minus h plus 2 is going to turn that minus h into a 0, negative 2x minus 0 plus 2. And since I'm running out of room, I'm going to skip the minus 0 part and leave it at that. That is my answer. It's a mess. There are shortcuts for this, and I will have videos showing you the shortcuts, but this is using the derivative definition, the huge limit crazy thing right there. Always expect things to disappear. Always expect to factor out an h, and then your answer will be a whole lot friendlier once this whole mess is taken care of.